Hello friends, a nice day to all. The video on the Hyper Raman experimental technique was here. I am Amarnath. Let's get into the video. The classical Raman, which was observed in 1928, it was based on the inelastic scattering of the photons, which results in the change in the energy of the scattered photons. The light from the laser interacts with the vibrational modes of the molecules to study the molecular structure, chemical composition, and other molecular interactions. The experimental setup was simple and the smaller data was obtained in the classical Raman. And this experimental procedure includes a monochromator and photomultiplier tubes in the experimental setup, which was simpler as compared to that of the Hyper Raman experimental techniques. The Hyper Raman is the nonlinear extended Raman spectroscopy, which has some technical advancements in it. The Hyper Raman uses the typical nanosecond giant pulse laser, which would deliver about 10 to the power of 17 photons to the sample at a single shot. There are two methods to observe the scattered radiation at such low intensities. In both the cases, the scattered radiation from the sample was collected with a wide angle lens and fed it to the grating system, which disperses the radiation. In single channel detection, the grating dispersion system works as the monochromator, which was set to pass radiation over the narrow frequency range, and the intensity of the scattered radiation is found by averaging the photoelectrons produced over a large number of laser pulses. This procedure is repeated spectral element by spectral element, which was very time consuming and very hard on the laser as well as the observer also. But in the case of multi-channel detection, the information from all the spectral element was received at desired spectral region for each laser shot. The grating dispersion system operates as the spectrograph, and the image intensifier intensifies the complete spectrum to a level which it can be seen by the television camera. The data was stored in the digital form and displayed in the analog form by the oscilloscope. Here is the block diagram of the multi-channel setup, which read and write the data simultaneously, and it transfers the data efficiently. And the multi-channel memory has the large bandwidth, which stores the wide range of data. The information or data which can be stored on the magnetic tape or computer memory. Though the procedure was complicated, the results can be achieved in the very less time. Hope you will find this video useful. Thank you.